Welcome to This Explainer. If you've been glancing at the news lately, you've probably noticed that getting the world to agree on literally anything seems harder than ever. But today, we're actually not going to talk about politics or clashing ideologies. Instead, we're going to dive into the hidden math driving our shifting geopolitical landscape. We're talking numbers, structures, and game theory. So let's kick things off with a pretty provocative thought. In the current global order, traditional institutions like the UN or the World Trade Organization are, frankly, proving ineffective at delivering global consensus. So the central question we're exploring today is this: are we entering a period of multi-party games where stable equilibria are just mathematically harder to reach? And, if our universal rules-based order is disintegrating right in front of us, what are the fields of convergence that can actually still generate progress? To unpack all of that, here's our roadmap for today's explainer. We'll start with the end of global consensus, move into the math of multi-party games, look at a case study on orbital debris, explore new fields of convergence, and wrap up with a future of minilateral clubs. All right, let's jump right into Section 1, the end of global consensus. Think about this for a second. We essentially built our entire modern global system on two massive bets: that a universal security body could stop wars, and a universal trade body could stop economic coercion. But the data tells a pretty stark reality. There were only 44 UN Security Council resolutions in 2025. That's the lowest number since 1991. The Security Council operates on a rule where any of the 5 permanent members can cast a veto. And today, that veto mechanism acts as a massive structural blocking coalition. It completely paralyzes action on global crises, because finding a resolution that all 5 vastly different powers agree on has basically shrunk to zero. And we're seeing the exact same paralysis over at the WTO, where a reverse consensus rule means just a single objection can halt the entire appellate system. Because appointing new judges requires unanimous consensus from 166 members, one single nation can hit the brakes on the whole shebang. And that's exactly what's been happening since 2019. Dispute resolutions have literally plummeted to a third of their pre-crisis levels. Which brings us to Section 2, the math of multi-party games. Now, rather than just pointing fingers and blaming specific governments for this breakdown, let's actually use game theory to see why aggregating preferences at this massive scale is structurally flawed. This isn't just bad diplomacy, folks. It's a fundamental math problem. We've moved from a relatively predictable bilateral game during the Cold War, where predicting your opponent's move was pretty straightforward, to a highly complex, chaotic, dynamical system. Today, we're in an N-party game. The number of powerful players has exploded. We've got fluid coalitions, rising powers, and even megatech corporations totally scrambling the traditional payoff calculations. So the absolute crucial concept here is the Nash Equilibrium. In game theory, you reach an equilibrium when nobody wants to change their strategy based on what everyone else is doing. But when you have dozens of autonomous players, settling into a stable, universal treaty is nearly impossible. A single action ripples through an incredibly complex web of reactions. It's like a giant puzzle where the pieces keep changing shape. We run into a few massive systemic math problems here. First up is the free rider problem, mapped out by Mancure-Olson. In a room of 190 nations, your individual contribution to a global good is so tiny, you're heavily incentivized to just sit back and let someone else pay for it. Then there's Lloyd Shepley's empty core problem. Mathematically, it's often impossible to divide the gains of a treaty without some subgroup realizing they're way better off just walking away to form their own bloc. And finally, veto player theory. As the number of veto holders grows, the chances of actually changing the status quo shrink down to absolutely zero. Let's ground this in reality. Moving on to Section 3, a case study on orbital debris. To make this math super concrete, let's look at the existential threat of orbital space debris. This is a perfect, real-world example of game theory happening right now. Every spacefaring nation completely relies on low Earth orbit. But clearing out old satellites and debris is wildly expensive, which means any cleanup benefits everyone equally, regardless of who foots the bill. Economists call this a common pool resource. Anyone with a rocket can access it, but if it gets entirely congested with trash, nobody can use it. Now, this perfectly maps the tragedy of the commons as a classic prisoner's dilemma, proving mathematically that both sides have a dominant strategy to just defect and let the trash pile up. Think about it. If clearing debris costs a massive amount of money, let's call it C, but the benefit of a safer orbit, B, is shared by everybody for free, why on earth would you pay for it? Your best move is to wait for your rival to spend the billions cleaning it up while you just enjoy the safe orbit. The end result? Nobody cleans it up. We hit a Nash equilibrium of mutual defection. And complicating the math even further is dual-use technology. If one nation launches a cleanup satellite, adversaries might easily see it as a tactical weapon, which introduces a massive security penalty. A satellite with robotic arms designed to grab a dead piece of metal out of the sky, well, it looks exactly like a weapon designed to grab an active military satellite. So now, you aren't just paying a financial cost to clean the orbit, you're risking a full-blown geopolitical crisis. This whole situation transforms into a stochastic Markov game, advancing through 3 terrifying steps. First, everyone free rides. But because orbital collisions create even more debris, the environment gets exponentially worse over time, in a feedback loop known as the Kessler syndrome. Once debris density hits a critical threshold, the game shifts. The systemic risk spikes, and eventually the cost of inaction, literally losing all your satellites, is so catastrophic that sheer existential survival forces coordination. It's basically a cosmic game of chicken. Okay, let's take a breath and look at Section 4, New Fields of Convergence. So, if the universal rules-based order is disintegrating, where is progress actually happening right now? How do we solve things before hitting that catastrophic existential crisis step? Well, cooperation hasn't just vanished, it's simply migrated. It's moved toward pragmatic, issue-specific corridors. Rather than trying to get 190 countries to sign a massive UN treaty, progress is happening from the bottom up in small, specialized blocks. We're seeing it in things like orbital traffic management norms, unified digital public infrastructure pipelines, and bilateral crisis communication channels that are designed simply to prevent accidental military escalation. The recent AI government summits are actually a brilliant live experiment showing how sequenced convergence works in real life. They're successfully building small, monitorable commitments before entrenched blocking coalitions can even form. They started small in 2023 at Bletchley, just agreeing on a shared vocabulary of risk. By 2024, they built a network of safety institutes. By keeping these commitments small, highly specific, and verifiable, they've managed to build an equilibrium of cooperation in a totally unprecedented domain. Which brings us to our final stop, Section 5, A Future of Minilateral Clubs. This right here is the big takeaway. If universal institutions are paralyzed by the math of large numbers, what's replacing them? The answer is minilateralism. By controlling the number of players and keeping their preferences highly homogeneous, groupings like climate clubs and security pacts actually make stable equilibria mathematically possible again. We are substituting the grand, universal coalition for a lattice of overlapping, purpose-built clubs. By grouping together just a handful of like-minded players, you shrink the number of veto players. You entirely bypass the empty core problem. You make the math work again. I absolutely love this recent quote from the World Economic Forum because it hits the nail on the head. Cooperation is like water. It just finds other ways. It perfectly captures how the human drive to coordinate simply routes around institutional gridlock when survival demands it. Just because the WTO or the UN Security Council are stuck doesn't mean the world stops spinning. We just find different, smaller, more pragmatic channels to get the job done. So I want to leave you with this final thought to ponder. We've seemingly solved the math problem by forming these smaller clubs, but will this fragmented, overlapping lattice be resilient enough to catch us when the next truly global crisis hits? Minilateralism fixes the immediate gridlock, for sure, but it naturally excludes people. It fragments the globe. As we transition into this complex new era of multi-party games, understanding these hidden mathematical structures is absolutely crucial to seeing where our world is really heading. Thank you so much for joining me on this explainer. I really hope this helped decode the fascinating math behind our changing global order. Keep learning, and I'll see you next time.